नमस्ते, वेलकम यू ऑल। इस लेक्चर में हम चर्चा करेंगे इवोल्यूशन ऑफ यूनिवर्स। जो ब्रह्मांड है उसका उद्भव कैसे हुआ, उसका विकास कैसे हुआ। बिग बैंग, बड़ा धमाका। बिग बैंग, however there are different theories, कई सिद्धांत है जो that will define the evolutionary form, लेकिन मोस्ट जो है रिलायबल है, एक्सेप्टेड जो प्रिंसिपल है वो हमारा बिग बैंग है। बड़ा धमाका, बिग बैंग का मतलब हुआ कि स्पेस में, वरीमा में जो भी गैसेस पार्टिकल्स थे वो जमा हो गए। Good number of, or you can say more or less an infinite number of gaseous particles because of their gravitational pulls, गुरुत्वाकर्षण के कारण वो जमा हो गए। और जब एक बिंदु पे जमा हो गए तो मास डेंसिटी बहुत ज़्यादा हो गया और टेम्परेचर ज़्यादा हो गया, हीट ज़्यादा हो गया, एनर्जी ज़्यादा हो गया, और जिस कारण से वो आया, गैसेस पार्टिकल्स आपस में मिले, और जब मास डेंसिटी बहुत ज़्यादा हो गया तो फिर रिपल्सिव फोर्स काम करना शुरू किया और फिर तब जाके वो एक्सप्लोड कर गया, बड़ा धमाका हो गया, बिग बैंग हो गया। और बिग बैंग हुआ तो जाहिर है कि वेरियस फ्रैगमेंट्स आउट ऑफ द बिग बैंग इन ड्यू कोर्स दे कूल्ड, वो ठंडे हो गए, और जब ठंडे हो गए तो स्टार्स, गैलेक्सीज, प्लैनेट्स, और फिर हमारा लाइफ शुरू हुआ। दिस इज़ इन फैक्ट द प्रिंसिपल बिहाइंड द origin of or evolution of universe. Most important point is that the universe began with the Big Bang. It expanded, and today also the universe is expanding. आज भी यूनिवर्स एक्सपैंडिंग है। हबल फिजिसिस्ट हैं जो वो कहते हैं कि जो भी गैलेक्सीज हैं और काफ़ी दूर हैं तो काफ़ी तेज़ी से वो गतिशील होते हैं। द स्पीड ऑफ गैलेक्सीज फार अवे फ्रॉम ईच अदर will have more velocity of separation than those close to each other, meaning thereby the universe is still expanding. Okay, there is Hubble principle. Now see something more about evolution of universe. As the universe its future is shaped by fundamental laws of physics. Utilizing a logarithmic clock, cosmologists can trace the evolution of the universe from the Big Bang to the present. As a Big Bang जो हुआ ये about 15 billion years ago, 15 बिलियन वर्ष पहले की बात है ये बिग बैंग। Now come to the stages in the evolution of this universe. The initial singularity. The universe begins as an extremely hot and dense point called a singularity. The point here. This marks the starting point of the Big Bang theory, where all matter and energy are concentrated in a teeny, infinitely dense space. Inflationary epoch. A brief period of exponential expansion known as cosmic inflation occurs within the first fractions of a second after the Big Bang. This rapid expansion helps explain the uniformity and larger scale structure observed in the present universe. Quark epoch. As the universe cools further, quarks and gluons combine to form protons and neutrons. This transition occurs in a matter of microsecond. Hadron epoch. Protons and neutrons continue to form and combine, creating a soup of particles called hadrons. This epoch lasts for a few minutes and is crucial for the formation of light elements like helium and deuterium. Lepton epoch. The universe becomes transparent as it cools, allowing photons to move freely. Electrons and positrons annihilate, leaving behind a small excess of electrons, which form the basis for the cosmic microwave background radiation. Photon epoch. Photons dominate the universe, interacting with charged particles. As the universe expands and cools, it enters a phase where photons no longer interact frequently, marking the transition to the era of cosmic microwave background radiation. Formation of a structure. Formation of a structure. Over millions of years, gravitational instability led to the formation of cosmic structures. Gas clouds collapse to form galaxies, stars, and other celestial structures, shaping the larger scale structure observed in the universe today. Stellar evolution. Stars form collapsing gas clouds, undergo fusion, and eventually exhaust their nuclear fuel. Depending on their mass, stars may end their lives as supernova, neutron stars, black holes, or white dwarfs. Stellar evolution contributes heavy elements to the cosmos. Galactic evolution. Galaxies evolved through interactions, mergers, and the continuous formation of new stars. Over billions of years, galaxies take on various forms, influencing the distribution of matter and shaping the cosmic landscape. Dark energy. Dominance and late cosmic history, a dark energy, a mysterious force driving the accelerated expansion of the universe, becomes more dominant. It contracts the gravitational pull, leading to an ever faster expansion. Beginning of end. Over time, stars will exhaust fuel, galaxies collide, and new stars will form merging brown dwarfs. Eventually, stars will be ejected from galaxies and black holes will dominate, consuming rogue stars until their evaporation. So, this way you have seen the various stages of the evolution of universe. To conclude, go back to 15 million years. There was a big bang, Bada Dhamaka, and I told you in the beginning that many more, very large number of infinite number of particles, gaseous particles, due to their attractive forces, concentrated over a point, and the mass density of that point became very large, energy became very large, and it was very hot. Then naturally, now repulsive force began to take place. Big Bang was there 15 billion years ago. Various fragments were there. In due course, they cooled down, and now our life began. Stars, planets, galaxies. Also, one most important features of the universe is with the Big Bang, 15 million years ago, it came to being, and since then the universe is expanding. And there is also the Hubble principle that supports the expansion of the universe. There is most important topic, that how the star began and how the star says goodbye to this world. That is the life and death of a star. This is very interesting topic. It needs discussions. In coming days, I shall be with a fresh lecture on life and death of a star. So, thanks for giving me a patience listening.